And I'll be sharing the recorded lecture with you as well. Okay, so let me go ahead and share my screen here. Okay. So first thing I have for you is a little assignment for you, like a discussion assignment for you guys. I think I can still hear some other sounds. Could you mute yourself, please? Okay. All right. So I have the first thing I want to discuss is just give you some time. So if you made this traffic safety facts screenshot available to you. So if you can click on it and take a look at this and just do a quick read of this, especially this part that I highlighted here, especially this part over here. And this is something that you will encounter a lot. Like, you'll hear a lot of people say this, that how 94% of the collisions are, in fact, caused by human drivers and so forth. I want to help you dig deep into a little bit. And this is basically the source here, right? This is that 94% plus or minus 2.2% critical reasons attributed to drivers, vehicles, environment, and unknown critical reasons. So this is basically all crashes that happened between 2005 and 7, and this is that study. And this discussion is from 2015. This is a February 2015 statistical summary. I want you to read through this, especially this part, over next 5 minutes or so. And this is also obviously available on your Canvas page as well. So if you can go ahead and read this, and then we can come back and talk about this. And I do have an assignment for you as well from this. So give it a read, either on your own screens or from Zoom screen, either way. I'll try to see if I can share the whole thing with you guys. Yeah, I think you should be able to read pretty much the whole thing from here to here. So I'll give you a few minutes to read this. Pause the recording for a second. Okay. So if you can raise your hand if you still need a little bit more time to read through this, Please raise your hand if you need a little bit more time to read through this. So if you don't raise your hand, I'm going to assume that you've read it. Okay, so I just want to go ahead and talk about this a little bit. So does anybody have any questions or comments about this? Let me resume the recording. So one thing I want to ask you is are there any questions or comments about this? You can raise your hand, put the question in chat. Maybe another 20 seconds or so. Any questions or comments?
I have a quick question.
Yeah, sure.
What would count as a recognition error?
What would count as what now?
Like it says in the bottom half of the summary section, it says among the drivers who were assigned critical reasons, recognition errors accounted for 41%.
Yeah,
What?
yeah, yeah. So recognition errors are basically, how sometimes what happens, in the police report, if you review the police, that's a good question. So in the police report, sometimes you will see like a description that says looked but didn't see. So what happens is that sometimes the driver's eye might be at the right place, but they don't react correctly to that situation because maybe they're thinking something else, or something else is going on in their brain that they're looking in the right direction, so they're not looking at their phone or anything like that. They just don't recognize the situation to be a crash prone situation. It's kind of like looked but didn't see. They didn't understand that. So yeah. And then I've gotten a comment. Does that answer your question? Does that make sense?
Yeah, that makes sense.
Okay, perfect. And then I got something in the chat, and the question says, critical precaution is basically a failure of the last line of protection. Yes, that's exactly what it is. And why I'm basically, providing you to this is like why this is sort of the first thing we are discussing in the class. And the reason for that I'm doing this is the reason for doing this in the first class is this, because what happens is that this is a 2005 through 2007 sort of study, right? They did, like you can see it here, 2005 to 2007. And what has happened is that because of these statistics, right, because of this table number 1 that you see, a lot of people misinterpret that to say that 94% of the crashes are caused by human error. Okay. And that's exactly what this highlighted area is also talking about, is that although the critical reason is an important part of the description of events leading up to the crash, this critical reason is not intended to be interpreted as the cause of the crash or the assignment of fault to the driver, vehicle, or the environment, right? So you will hear, based on this exact data, you will hear a lot of people, even practitioners, talk about, driver error as sort of being the cause of 94% of the crashes. And a lot of these automated, vehicle manufacturers and service providers, they will latch on to this statistic using the same thing, like they say that. However, Federal Highway or sorry, NHTSA is very clear about, so this is National Highway Traffic Safety Administration, through this research summary, statistical summary, they're very clear about that this is not the goal of this statistic or that research. This is not how this 94% statistic should be interpreted. And the difference is a little bit subtle, so I can see how people might mistake that. But the difference is subtle. You can, this is not to say, again, the big takeaway for you all is that if somebody is saying that 94% of the crashes are caused by driver error, you should be, refuting that. That's definitely not correct. That's not what this statistic says, right? And why is that? Why is that interpretation not correct? I'll tell you why. It's not correct because, in the chain of events, the difference is that, in 94% of the crashes, it was possible for the drivers to do something that could have prevented the crash. It was possible. But that does not mean that just because something was possible, that does not mean it was probable or one should be expecting, drivers to be able to do that, or drivers to be able to do that all the time, right? So you can think of it this way, right? Just because it's possible for, somebody to be able to lift a certain amount of load, right? Like, it's possible for human beings to be able to lift whatever the Olympic gold medalist in weightlifting can lift. It's possible, but is it reasonable to expect every driver in all possible cases to be able to do that, right? It's not. It's not reasonable for us to do that. And that's exactly the idea. Like, it's possible for drivers to be able to do that. And yes, if they were absolutely alert in all cases, maybe they will be able to do that in more cases and avoid some of the collisions. But attributing 94% of the crashes to the drivers because of this statistic is completely unreasonable. Okay, so that sort of is the discussion I wanted to have in the class. But then I have a question for you that I want you to be able to answer. And again, this doesn't have to be like, a lengthy paragraph or anything like that. All I'm looking for is like a two to four sentences for this discussion quiz. And that quiz is basically this, right? If I click on this to take the quiz, based on your review of the highlighted, and I'm going to not talk about that in the class right now. I want you to kind of originally think. And I know you might be consulting ChatGPT, and that's fine. If you do ChatGPT to answer this question, I'm fine with that. But don't just copy paste what ChatGPT says, because I'll know what ChatGPT says, right? So just critically think what ChatGPT says and then provide me with the answer. Okay. So based on this review, what do you think are the implications for the connected and automated vehicle, right? So just I want you to kind of think about that statistic, and how saying that 94% of crashes are caused by human driver is a misinterpretation of what it says. And I want you to kind of, give me, its implications and on based on your, so that's all I want you to do. I don't have a due date for this right now. I don't have a due date provided for this, but what I want you to do is definitely submit it by the end of the lab, by end of the lab tomorrow. I mean, on Monday, end of the lab on Monday. Okay. That'll be great. Okay. Matthew, you have a question, please.
Yeah, can you explain what a connected vehicle is? Like, I understand an automated vehicle might be like a Tesla that can drive itself. Is that correct? Or
Yeah. So CAVs, when I'm talking about CAVs, like this is one term, connected and automated vehicles. That just means that's exactly what I'm interpreting it as. Like, if a CAV that can drive itself, right? What is that like? So yeah, so I'm basically, what I mean by that is a vehicle that can drive itself based on the information that it collects from its environment, but also from other vehicles. So a connected vehicle would be connected and automated vehicle would be a vehicle that can drive itself, but then also it's collecting information not just by its own sort of sensors and devices, but a connected and automated vehicle will be, it drives itself, but it also making use of information that might be coming from, the internet or from other vehicles and so forth. Maybe some communication between multiple vehicles and vehicle and infrastructure. So a connected and automated vehicle would be a vehicle that drives itself using information not just from itself, but also from other sources. But for the sake of this discussion, I think you can focus on this to be a vehicle that somebody's thinking about in terms of vehicle that can operate by itself. So it has like a certain level of automation. Okay. All right. Good question. Any other questions, comments? Okay. So I haven't assigned a due date to it yet, but I want to, and I'll remind you that, like, maybe in the lab you can take some 5 minutes or something to submit that. I'll maybe just give you some time to do that in the lab too. But again, if you want to just quickly get it done, I think that'll be great, because in the lab we'll be working on another assignment. All right, good. So next thing I want to do is talk a little bit about this idea of human factors, right? So there is a lot of, human factors and this is related to the driver error question that we just discussed. And human factors like human interaction with the infrastructure as drivers, as pedestrians, as bicyclists, drives the design that we provide, right? That drives the design that we provide, that should drive the environment that we provide to the road users, but it doesn't always do that, right? So that sometimes is the problem. And we will talk a little bit more about this, but from a safe systems perspective, and we'll dig deep into what safe systems mean. But the idea is of safe systems approach is that you anticipate human error. You always anticipate that the drivers and the pedestrians and the bicyclists are going to make errors. And as they make errors, how do we make sure that their errors are not deadly? They don't lead to, you think about this, right? We still have death penalty in this country, but we reserve it for, heinous of the heinous crimes, like the worst of the worst crimes is what we leave the death penalty for. And in a lot of states, we don't even do death penalty for any crime at all. And having somebody die because, they were looking elsewhere, or they were just careless, or they didn't wear their seatbelt, that seems like a minor error compared to what the death penalty is reserved for. So I think we should be doing everything in our power so that these minor errors do not lead to fatalities on the road, right? So if you look at it from that perspective of what we provide death penalty for, and in some parts of the world and some part of this country, we don't even provide death penalty for the worst of the worst crimes. So it should definitely be unacceptable to have somebody dying for the errors that they make on the road, right? So that's how I sort of think about it. And then when I did first time thought about it, when I first thought about it this way, it really did, solidify the belief for me that traffic safety is such an important concern. Nobody should be dying for a small mistake that they might make on the road. Okay, so anyway, so that's where the human factors come in. Expect driver errors, expect pedestrian error, expect road user errors in all situations, and see what we can do to avoid those. So that brings us to the definition of human factors. It's an applied discipline dedicated to enhancing the relationship between devices and systems and the users who are meant to use them. And then the key point that I want you to take away is that the user is the focal point, right? So we have to think of in terms of the users. And if you kind of go into like fatal crashes, about half of the fatal crashes in US have driving error as a contributing factor, not necessarily, the contributing factor, but as a contributing factor. And this is about fatal crashes only. So again, this is far cry, obviously, from the 94% statistics that sometimes people will quote at you. But again, it's as a contributing factor, not the contributing factor, right? But still, we wanna be able to avoid that. And how do we make the user the focal point? And that might require the road designer, the engineer, the planner to kind of be in those shoes of people driving on that road, people being pedestrians on that road, and so forth. So background, a published resource on aid in safe roadway design and operation decisions. So where do these standards that we use come from? There is AASHTO Green Book. There is Manual for Uniform Traffic Control Devices, MUTCD. And then there is the Highway Safety Manual. Now, if you look at the first two, the AASHTO Green Book and California MUTCD, we have, the federal MUTCD, we have California versions for both of those documents as well. So California has its own highway design manual, and then it has its own sort of like and they mirror each other. They're very close to each other. It's not that, the California Design Handbook or California MUTCD are totally different than federal ones, but they're very similar. But California does have its own document. And we use these documents all the time. But what you would find is that lot of information, especially on those first two documents, the AASHTO Green Book and its California counterpart, and then the Manual for Uniform Controlled Devices, MUTCD, and its California counterpart. You will find that a lot of standards are not necessarily based on a lot of research, right? So if you look at these two standards, there could be a lot of limitation, right? So what I want you to think about, give it a couple of minutes, and I want you to think about, and then we've seen like, use of highway design standards in CE 321, for example, right? We do talk about some information from that. We don't talk a lot about MUTCD in the CE 321 class, but maybe you've taken CE 421 traffic engineering class, or in general, like thinking about design standards or minimum radius required, or the super elevation required, or the turning radius, or the speed on design speed on a curve, and sight distances and so forth. So think about those types of standards, right? What are some of the limitations of using those standards? So if you could put those in the chat, that'll be great. So take maybe a couple of minutes to think about it and try to put them either you can put them in chat or have them written on paper. So, and then when I'm going to ask about it, you can respond to me and provide some of those either via voice if you've taken it down on paper, or you can just read it off your chat. So I can just read it off your chat. So just think about what do you think are the limitations of just using existing design standards. Okay, so I'm going to pause here. And if you can think of some limitations and provide me with those limitations. Okay, I see some response in chat already. That's great. Very good. Yeah, some really good ones in the chat there. That's good. Yeah, some very, very useful ones. So good. Like I love the responses that I'm seeing in the chat. This is so great. Unless you've already looked at my list, right? That list is available to you as well, right? So, but this is good. Yeah, no, this is. Wow, this is good. Okay, so I see a lot of responses in the chat. That's so great. I love these responses. Very, very, thoughtful discussions here. New technologies about just only certain types of road users, like the drivers alone. So those things are really, good, interesting points there. Yeah, if the roads appear safer, the drivers will drive faster. So I think which road users do we create the forgiving environment for could be useful, because the vehicle already is a somewhat forgiving environment, right? Like, the car occupants that have been going down. So that's nice. Outdated assumptions focus on roadway speed. That's good. Existing standards don't take emerging technologies into account. And then Set reaction times is 2.5 seconds, but that can vary based on demographics, right? Yeah. Standards take time to change, new technology that comes in. This is very thoughtful. Thank you. Yeah, outdated assumptions. So yeah, I mean, these are all great suggestions. I have some of my own here. Oops. So you can take a look at it. I'll let you read those in a couple of minutes. I'm trying to find which I haven't seen yet. Yeah, so I see, the overly simple models one, what road users see or do. So maybe human beings are more complicated than that. And then same thing about incorrect assumptions about capabilities and limitations. And the technology thing came up. This one came up as well, special needs. And adequately address trade-off between conflicting demands that are related to important. And we'll talk about this a little bit. And this is conflicting demands could be about attention, like where the drivers are paying attention. And then, this last one is also very interesting, and I don't think it came up in our chat there. But this last one is about specific combinations of roadway design features, right? So if you look at like any of these design standards, right, they're all sort of focusing on. So when you're talking about vertical curve or horizontal curve, they're focusing on that one piece. But when more than one element comes together, right, specific combinations of roadway design features could be trouble, right? So maybe one particular design feature might be fine in one location, but then if it's combined with another design feature, that could be more problematic. So those are the things that folks have to think about as well when we are talking about existing standards. They don't account for combinations of roadway design features. They're always looking at single one. So here is just kind of going back to the roadway system. You have different elements of the roadway system, so different components. Obviously, the road is a system, a component. There is users, cars, truck, pedestrians, and then there is traffic control. Traffic control could be your lane markings, for example. It could be signs, the slower traffic keep right signs. So these are all sort of regulatory signs. So if you see any kind of white sign, that's a regulatory sign. That means it can be enforced. But then if it's a yellow sign, it's on merely an advisory sign. And there could be more than one type of road user on the road. So these are just kind of reminding you of components of the roadway system, right? So these are different components. And for roadway, engineers, the traffic engineers are primarily they're not designing the user, they're designing the roadway environment, and then they're designing the traffic control. That's primarily what they're controlling, this traffic control and the road. So here are some example problems that come in. So because of specifically related to human factors, so drivers experiencing difficulty at intersection in estimating gap size and speed of approaching vehicles. And again, think about this, right? In some cases, that's fine, right? In some cases, gap size and approaching speed, even if drivers have some difficulty, they can make more conservative assumptions. So think about like a permitted left turn, where the drivers are making a left turn either on a flashing yellow arrow or on a green ball type of light. So there's absence of red arrow. So the drivers may be making left turn, but they might have difficulty in estimating gap size and speed of approaching vehicle. But that difficulty depends on the roadway environment, because if there's only one lane of through traffic that they're crossing, maybe we are okay. Maybe we can let that drivers decide. But if they're crossing 3 lanes of traffic or 2 lanes of traffic, then their difficulty in estimating gap size and speed of approaching vehicle could be much worse, right? Their difficulty level might be much higher. drivers might experience difficulty in detecting a sharper curve after negotiating several longer radius curves. So these longer radius curves are typically going to be more sort of, easy to navigate for the drivers. But if they've done that for for a lot of not sharp curves, and then suddenly there is a sharp curve, then it might be a good idea to provide those drivers with a warning of some sort. Right? So those are the things that are important here. Additional distance and times might be required to slow or stop under adverse weather conditions. So that's another thing. Additional distance and time might be required under adverse weather conditions. And again, depending upon what type of weather you're dealing with, those things could be useful as well. Excessive messages on changeable message signs can inhibit correct decisions in traffic flow and safety. And there is a very interesting study that I'm going to try to introduce you to in the next class. It was a very interesting study. They did that in Texas, where the drivers were informed of how many deaths have happened on that segment of the roadway. And they found that those types of signage actually increased collisions on the segment of the freeway. So what type of messages you are putting on the changeable message sign, sometimes those things could backfire as well. So we'll talk about that. I'm going to make a note for myself to provide you with that with that study, so we can have like a small discussion on that. So that's something I would like to do. User decision making takes time, but and users can only react to about 1 to 1.5 information tasks or actions per second. They can have information overload, and then that's the other thing about the vehicle environment that we are navigating. I think there are a couple of auto manufacturers that are still focused on sort of physical buttons, but most of them have gone away from that, and they might be bringing them back because the drivers find the screens very distracting. Even though they like it, they like to have it in their cars, those touch screen controls and so forth, but they can create a lot of distracting environment for the drivers, right? So these are some of the example problems that can occur when you're not properly accounting for human factors and you're just basically just following the design standards. So then these are some of the things that you might be missing out on thinking about. Any questions so far? No questions. I'm seeing none in the chat. Good. So here is the question about, so this is like a one human factor experiment that was conducted as part of this is the human factor experiment that's described in your human factor guidelines 600A. So I'm just going to go ahead and open that one too a little bit. Again, you don't have to print this whole thing out, but there is some interesting things that I'm going to have you work on using this human factors guide. This is an old NCHRP report, not very old. This is like NCHRP report 600A. I think this was published in 2008. So this is old, but this is still very relevant to human factor design. So what it does is like it forces the system designers or traffic engineers to find information like a road user, right? So they want you to kind of have you think about, as a road user, how the road users are going to seek information, how are they going to apply for information, or how they're going to react to that information and so forth. And it has a bunch of different, guidelines. And this is basically what I've been, working through that. And this is what you have to think about. And then what they had done is like, this was their experiment for a driver. Okay. And this is about what drivers choose to focus on versus not. Okay, so I want you to think about this a little bit. So what they did was they showed a bunch of recruits, the survey recruits, this image of the roadway, and then they didn't show them obviously the dotted image. They showed them this image right here. They showed them this image. They showed them this image right here and asked the road users, what is the most important information to them? They had them react to most important information. And a lot of, most of the folks said, they were looking at roadside. This is everybody's response in general that look, some of them pointed out like, the most important information for them was that this, what's happening right in front of them, like what's happening. They were focused on the road, but they also wanted to see if this car is going to pull out or something. And some of them pointed out that this is what they want to see. But a lot of them pointed out like, this is where the most important information was, what the drivers were looking at straight ahead. And in the same environment, if you put in an oncoming car here, like same roadway place, now, if you're analyzing this particular environment that you see over here, almost everybody said the most important information was right there. Most important information to most people was what that oncoming car is doing. Right? So what drivers deem to be most important changes based on what's happening on the road, which makes sense, right? This is how it should be. But it has certain implications for how we design the road. For example, look at this picture, right? So I'm going to show you this picture right here. This is the roadway location, and this has a little bit of a hill block view type of situation, right? This is something, this is probably like a vertical curve. It's a hill, and what this hill does is it makes it harder for the drivers to spot what's happening beyond this vertical curve, right? Because once the roadway goes down, this is blocking their view. Now, when the drivers were asked for this environment, what is the most important information, and MMI being most meaningful information, guess what they responded with? They responded with this thing right here. They responded with this right here. Right? So I should probably make it thicker. They responded with their focus being over here. So a lot of green signs over here. What's the problem with this? The problem is the drivers are focusing on the speed limit sign as their most meaningful information. But it's a hill, whereas they're driving on this road right here, as they're driving on this road in this direction, right? They might miss out on if there is like an obstruction here, or if there is a parked car, or if there is a car that suddenly has stopped in front of them. They're not paying attention to that location, even though the hill is blocking view, so they might not have enough sight distance, or even if they have, they might have just adequate sight distance here on this road, but they're focused on the speed limit sign. So that has an implication for you as a human factors, person or a road traffic engineer. You might want to think about, hey, I probably shouldn't put a speed limit sign, which the drivers deem very important information because they want to avoid getting a ticket, that it distracts them for what is really meaningful in terms of crash avoidance at any given location. Does that make sense? Like how human factors can decide or can guide where you put a speed limit sign and specifically where not to put a speed limit sign. Right? So that's something that, you want to think about, is that, even when you're investigating collisions or something, and if you're seeing collisions at a roadway location and you're thinking of cause of that collisions on those roadway locations, you have to think about, okay, have I placed something on that roadway environment which is taking the attention from the drivers and directing it in a place where they think it's the most meaningful information for their roadway environment, when they have something in reality more meaningful that can help them actually avoid the crash. Okay, so this idea of most meaningful information is really critical in roadway design, in human factors, in trying to address the human factors for the roadway. Okay. Okay, I need to clear this. Now there is a car in front of them that probably changes a little bit. So you can see that like more people were just focused on the speed limit sign. When there is a car, some people did shift, but you can see there is still a lot of people who are saying that, the speed limit sign still remains the most important information. So that is the sort of the challenge of, your safe systems design or safe roadway system. Let me clear it all. Okay, so for safe roadway systems for us to have safe roadway system, or for us to design safe roadway system, what we need to do is we need to become virtual road users and avoid unintended use of the infrastructure, inconsistency of design and traffic control application, large differential in speed, and uncertain road user behavior. Okay, so that traffic engineer and the highway designers, they need to work together to make sure that we are doing that, we're providing that safe systems. And when we are thinking about safe systems, again, it becomes very important for us to think about what is the roadway environment that the road user is going to scan in each step, like as they're driving by, or if they're walking, or if they're a pedestrian, or if they're bicyclists. What is the length of the roadway environment that they are, examining? And then examined roadway environment could go as far as the sight distance, right? So whatever sight distance they have available, hopefully they're utilizing all of it, and they're scanning that much road environment. And you could see that, that could change, because remember, the sight distance change based on the speed that you're driving at, right? So you need to be able to see more of the roadway if it's a high-speed facility, right? The more of the roadway must be visible to the driver. So that scanning step size, it varies based on certain factors. So I want you to, again, take a minute or so to think about, like, not look at the slides, but think about, what do you think changes the scanned step size for drivers? What changes the scanned less step size? What factors might influence how much is the step size? Like, what does this size depend on? Like, how long this is going to be, that the length going to be that the drivers are able to scan? What factors does that depend on? You can put the responses in the chat. I see a couple already. Yeah, speed of travel, that's good. Other factors. The terrain, other cars, or the road blocking the view. Yeah. Speed and topography, that's very good. That's exactly what it depends on. The weather, yeah. Yeah, how many curves and what's along the way. So that's basically the curves are going to be determined based on the topography of the area, and what is along the curve, what's happening. Yeah. Yeah, some good responses there. That's very good. Thank you. So yeah, so scanning step variables can be based on, and they could depend on, like, a lot of different factors, context of the surrounding area. It's all very good. And you could see that they could be user-related factor, that could be operations, how the operations is going, the roadway-related factor, and then the environment itself. And you can see so many different things that can affect that step size, right? It's the user's age, user's vision, user's experience, cognitive ability, road familiarity. For operations, vehicle type, speed, if it's a one-way or a two-way traffic, if it's like, what type of control do you have, right? So that how much you're able to scan depends on whether you're coming at a complete stop or whether it's a yield sign, right? So it all, varies based on that. And then there is highway, like what's the functional class, and that will determine lane width and shoulder width and side distance, pavement type and condition. Function class, condition of the roadway, roadside, grades, curvature, all these things, they are related to topography, for example. And then some of you talked about the environment, whether it's an urban environment, how many pedestrians and bicyclists there might be. If it's a scenic route, right? So there is a lot of, folks who are concerned about when the ocean first becomes visible when you're headed to Pismo Beach. That's something that where traffic always seems to slow down for no apparent reason other than the fact that the drivers have just seen the ocean and they want to, gawk at the ocean, right? So those kind of things do happen quite a bit. But then all of that changes. How much step are you able to scan? Then the scanned step size become much smaller and so forth too. So you have to kind of look at that, carefully. Questions, comments, any other thoughts that you were thinking about that didn't come up here with regards to what impacts the step size? Okay. Not see any questions. It's okay. Okay, so now next thing I want to do is like just kind of have a quick discussion on the example guidelines, how the human factor guideline guidebook provides the guidelines. So let me quickly stop share. Oh no, I don't have to stop share. Let me just pause here. So if I go back to this documentation, but the key here is to think like the roadway user, right? So if you look at the human factor guideline, they provide like what the template looks like. So it's a 2-page format, so it's very easy to scan. In the human factor guidelines, a consistent 2-page format is used to present the individual human factor guidelines, right? But each page, there is a main issue being addressed. So this is like the left-hand page. There is design guideline, feature, figure, table, or graphic, some discussion, bar scale rating. Like, if you look at the bar scale rating, that's about based primarily on expert judgment, which is a euphemism if the experts have just pulled it out of their hat, which itself is a euphemism for something else. But, if this is based on just primarily on expert judgment or based on primarily on empirical data. So the further this bar goes, the more reliable that human factor guideline is, right? So any guideline that you're looking up from the human factors, how reliable is that guideline? If it goes all the way over here, like for example, it goes all the way right there, right? So that's kind of like, it's still very close to based on primarily being on empirical data. So that's good.
Professor,
Go ahead.
I don't think you can see what you're talking about.
Could you repeat that, please?
The
Sorry.
screen share still on the step varies.
No, I'm talking about.
I don't think we can
I'm
see what you're talking about. We're on the scan step varies. The screen might be different.
Oh, you're not seeing the screen?
Got it.
Are you seeing this correct screen now? So you should all be seeing the screen for the NCHRP report 600A rather than the slides.
We're just seeing the slides.
Oh, you're still seeing the slides? Huh.
Yeah.
So does it only share the tab? I thought it shared the whole. Okay, I'm going to go ahead and stop share and then reshare. Okay, do you guys see the PDF file now? Not the PDF. Oh,
Yeah.
You see the
Yeah,
code? Okay, good. So you should have like the template that they provide for any human factor guidelines that you might review, right? You're seeing the template now?
Yeah.
Okay, perfect. Great. So that's what I've been seeing, but I'm glad that you pointed it out. So yeah, please always point out if there is some problem with what you're seeing, and So that's good. So what I was trying to say earlier was they have provided like a consistent form for everybody to look at. And so, for example, the first thing that they provide is some introduction, some background, this guideline title. So the key components of sight distance is the guideline. There's an introduction, and then there's bar scale rating. And that's the bar scale rating I was talking about. If something is based primarily on expert judgment, then basically that means that some engineer 40 years ago just pulled it out of their hat, right? And then, or if something just, if the gray bar sort of progresses and goes all the way up here, that means that guideline is very reliable because that's based on empirical studies. So this goes all the way up here. It doesn't quite go fully on the bar, but it kind of goes like almost 9/10 or 8/10 of the way. That tells me that this is something that's based on some empirical data at least. So that's a reliable guideline to me. And then what's the guideline? Sight distance is distance traveled by driver perceives plus distance traveled by the driver completes an appropriate maneuver. So it's the reaction time and it's the maneuver time. So if you add to that, that's the distance that you travel during reaction time and the distance that you travel during the maneuver time. So you have to add those up to come up with the total total sight distance that you require. Okay? So, and then they have some discussion on it. So then they'll have a graphic, and they'll have some discussion. And once they have some discussion, they'll have some tables or something to go with it. There might be some cross-references if there are other types of guidelines that are either affected by it or they affect other guidelines. So they'll provide some cross-references there. And if there's some key reference studies that might be there, so they provide that as well. Okay. So this is sort of one way to look at this guide. And what I want to do here is I want to look at the guide on right turns on red to address pedestrian safety. So I want to look at this guide 11.4. So I see something in the chat. Yeah, exactly. So you will see that gray bar that I was talking about. So I'm trying to answer Hans's question on the chat. So that gray bar, is this about a trustworthiness rating of various human factor guidelines? I wouldn't call them nominal safety metrics, but I'll just call them human factor guidelines. So yeah, it's a trustworthiness rating of the human factor guidelines that this provides. Yes, that's exactly what it is. Okay, so let's look at that 11.4 and then have some discussion on that. I'm going to go to chapter 11. Again. So I want to look at this 11.4, restricting right turns on red to address pedestrian safety. Yep, this is the one. This is page 11.3. So now this is page 11.4 right here. You can see that at the bottom, right? This is chapter 11.4. So you can see that this right turn on red, the guideline, is not as, based on empirical data as the one that I was showing you earlier about sight distance. So that just means that whether or not to prohibit right turn on red at an intersection there haven't been as many empirical studies as there have been about the sight distance that I was showing you earlier. Okay, so you could see that. What's the design guideline? Restrictor on right turn on red can be used to reduce conflicts between pedestrians and turning vehicles and to increase the likelihood that the drivers will stop before turning right at an intersection. So that's the purpose of this guideline. The most effective method is to base turning restrictions based on time of day. That's fine. Basing restriction on presence of pedestrian will also reduce conflicts, but this approach appears to be significantly less effective than time-based restriction. Okay. So you can see that the countermeasure example, no turns on red, 6 a.m. to 6 p.m. Monday through Friday, most effective. But then, no turn on red when pedestrians are present, that could be tricky. because then the drivers can always like, maybe not even see the pedestrians, right? For whatever reason. Sometimes they will have the right turn vehicle to be allowed to have that stop bar a little bit further up front. So you can see that they're providing some example of RTOR signage that you need to provide based on these human factors. And you could see that this is like they've moved the stop bar for the right turn a little bit further ahead. So you could see this vehicle being able to stop a little bit further ahead. Why? Because they want them to be able to see what's happening and where the pedestrians might be. Okay. So when the sight distances are problematic, this is what you might want to do is like provide that additional, buffer for the drivers to be able to come up a little bit further ahead. And then they have whether or not what's effective. There is like, when the right turn on red is in effect, they provide the sign versus they don't provide the sign, so forth. And then they have like different countermeasures to encourage drivers to stop as they are driving through. So red ball on NTOR sign, most eye-catching, where this will be a preferred application. Effective signing application in most situations, so that's a good thing. So what they're doing is they're looking at these human factor guidelines and they're suggesting countermeasures that account for the human factors in that context, right? So this idea, this picture, can you look at these 5 countermeasures or 6 countermeasures that are provided in this column? Please look at these 6 countermeasures and figure out which one is this referring to. What would you call this countermeasure that I'm highlighting here? You can put that in the chat. Yeah, that's right. It's the offset stop bar, right? Provides improved ride distance for RTOR vehicles. So it might be effective. It's 2 or more approach lanes where there is heavy truck or bus traffic or unusual geometrics that limit the sight distance, right? So there is some discussion around that. But what they're saying is that several factors can diminish the effectiveness of RTOR restriction on driver compliance. If you have confusing partial prohibitions, right? 7 to 9 p.m. except Sundays, if you're writing too much there, that could be very confusing. You will see that your compliance rate will go down because of it. If there's long cycle length and you're providing right turn on red, that could be problematic because then the drivers are going to get antsy, and that would be a problem. You're confusing multi-leg intersections. Again, those things could diminish whether or not drivers obey that sign or not. And one of the other things that's happening with these human factors is that we are finding, because the current guidelines tell us that, there should be a sign at every location where you're banning right turn on red. Some cities that want to ban, like do a blanket ban on right turn on red, are finding it hard to do because providing all this signage on each intersection approach could become cost prohibitive, right? So, and this is interesting because some cities in the US, for example, New York City, it bans right turn on red at every intersection, right? New York state law allows for a city to be able to do that. And I think, that's something that California legislature has also been interested in, is kind of writing some guidelines or writing state law that allows for cities to be able to ban this. But again, this is a political hot potato. So there is still like a lot of debate that's going to happen. And then we're going to have to figure out the right direction. And then again, the other thing is these cross references, they design, so this section is cross-referenced in section 5.6, where you're looking at intersection sight distance, and then sight distance is right skewed intersection. Again, the right turn on red prohibition strategies might become useful there as well. So I hope you get a sense of like, how you review, and then you'll see that this is the exact same format that we use in pretty much every one of these human factor guidelines. They're all 2 pages, limited 2 pages. They have some information, and then they have some discussion. They have some cross-reference and so forth. So what you need to be able to do is review any of these human factor guidelines and answer any question that I might ask you based off of that. right? So now that you have some experience being able to do that, so that would be, one of your future homework assignments is like, I might have some questions about, hey, review this guideline and answer my questions about that. So that could be, so you should be able to interpret that. Again, this would be an open book type of question. Even if I'm giving you in the test to interpret something, I'll just straight up provide those guidelines to you. So you don't have to memorize anything from these guidelines. Just make sure that you're able to review these. And I might even ask you, like, give you two different guidelines, and I might ask you, which one do you think is more, based on empirical data? So you need to know how to find that information in these two charts. Okay. Any questions about these guidelines? Any questions? Okay, great. That's great. So if there are no questions, that's basically concludes the lecture for this class, this human factors lecture. So I'm going to go ahead and stop here. And then obviously from next week, we resume regularly scheduled programming. We meet for the lab. And then and I'll talk a little bit about the lab here, but that does conclude my lecture for today, unless you all have any questions. Again, you can ask your questions via chat, or you can ask your question via just unmuting yourself and just asking that question. Okay, and I'll record this lecture and the previous lecture. I have recorded both of these lectures, and I'll make sure that they are available to you to view over the weekend. So I'll make sure that it's available. Okay, I see something in the chat. Yes, so this NCHRP 600 report is in Canvas. Yeah, so if you go to Canvas page here, 526 Canvas page. So yeah, so this report is in fact available in Canvas. So if you look at that NCHRP report 600A human factor guidelines. So if you click on this, that takes you there. Yeah, this is the PDF file. Again, you don't have to print out the whole thing. Just make sure that you are able to review a couple of them at least, a couple of these human factor guidelines, and feel good about interpreting them, interpreting those information. Because, as a safety practitioner, that's going to be your job, right? You almost never have to remember anything. You just have to be able to read any kind of scientific or practitioner document that's provided to you and make sure that you are able to interpret that for the situation, for the problem that you're trying to solve. Okay, so that's basically the goal here as well. It's just to give you some ideas on or some experience and some practice on being able to read these documents. Okay. All right, so I'm going to go ahead and stop this lecture, but I do want to talk about the lab for a second. And this lab is also now available on your Canvas page. So if you go, okay, first of all, are there any students who are still on the waiting list by any chance? Are there any students here who are on the waiting list and need to get to the class or need to get in? Okay, so you're all enrolled in the class. That's good. Okay, so what I'm waiting for is, like, I haven't assigned the groups for this lab yet. And I haven't done so because there will be one part of the lab that's going to be individually done, but then there's going to be another part of the lab that's going to be done in a group. But I haven't assigned the group because I want to make sure that if there are still folks, because there was somebody on the waiting list before, I want to make sure that if they've joined in and they can do, because the permission numbers only become available tomorrow. So it looks like we don't have anybody, so that's fine. So I'll assign the groups over the weekend, and then we can start talking about the group assignment on Monday. But in the meantime, you can look at that individual assignment. So if you go to your Canvas page for this class and go to the labs section, lab number 1, exploration of crash data with TIMS, Transportation Injury Mapping System, TIMS. Click on this. That shows you a Google Doc link. So if you click on that link or just copy paste that link, you will be able to go here. And first thing I want you to do is just create an account so make sure that you do that account making process before the lab on Monday. So you're kind of hitting the ground running. You do have, registration is free, and it's a UC Berkeley maintained website. So I'm not worried about you providing any information to them. That's perfectly safe and reasonable to do so. And then individual account, current list of the currently maintained tools on the portal, description of each tool, and then report the importance of California safety performance management target setting tool. Okay, so that's something you're going to be reporting. And then I want you to find this 3 counties. I want you to be able to kind of look at these and answer these questions. 3 California counties with highest number of fatalities, 3 California county with highest rate of fatalities, and then 5 California county with highest number of injury fatalities for non-motorized road users. Okay, and then you will be including that as an appendix for your report. So again, I want you to do this individually. All of you should be able to derive this information from TIMS database. And again, it's not due right away. So you can take your time to do that by Monday, but at least I want you to be able to have created an account. Even if you don't do this work by Monday morning, that's fine. You will have time to do that in the lab, but just be prepared that you do need to answer these questions. Okay, and again, that part of the project is in fact individual assignment. Okay, so that's your sort of, I'm just prepping you for the lab a little bit as well. But if you have any questions, please let me know. Yeah, let me know if you have any questions. And if not, thank you so much. And I'll see you in person on Monday, 8:10 a.m. Okay, I see something in the chat, so hold up. Okay, that's just thank you. So that's good. All right. Thank you, and I'll see you Monday. Thanks.